Okay, well, congratulations on getting through the first chapter. Hopefully you've had ample practice on it by now. The first chapter or the first unit was obviously difficult. There's some difficult concepts in there. The second chapter, I haven't done every little bit myself just yet, but I noticed that there are exercises up to 2S. So this is another beast of a chapter as well. In fact, I was just looking at working out a percentage there, geeky kind of thing that I do, the first and the second units take up something like 18% of the pages in the book, approximately somewhere around there. So, given the fact that you have 11, let's just check here, was this 83? Given the fact that you have, I think, 11 units to do, let's just check it out. Yeah, 11 goes up to some statistics there, and there is a 12th unit, which is about the IA, so about the exploration as well. Okay, what was the page? I can't remember. Okay, so this one is about, Unit 2 is about functions. There we go. Representing relationships and functions, and you can see some of the micro concepts that they're talking about there. Some of these things you'll be familiar with from before. So functions, domain, range, composite functions, quadratic functions, transformations, odd and even functions, and partial fractions is being put in the end there as well, which wasn't in the previous HL course. So that's interesting. Okay, so there's some stuff about what you should know before you start, and I'm just going to skip over that because, after all, you should know it. And then there's a little investigation to start off with 2.1, and I'm going to skip over this as well, but then come back to it in a bit. It basically just says, well, what do you notice in each of these two columns? I'm going to skip over it just for a moment, and I'm going to go directly to the definitions here. So let's just go me. I need to see me throughout. Okay, so they talk about two things. They talk about a relation to start off with. Essentially, we are leading to graphs on Cartesian grids, and we'll talk about that in a bit. But they start off with the first definition in this red box. They say a relation R is a set of ordered pairs, x, y, such that x belongs to a certain set and y belongs to another set, the set B, and that these sets are non-empty. Okay, the empty set would be the null set. You've probably done a bit of set theory before, but again, we'll deal with that when we need to. And then it says a function, so more than a relation. So a function, f, is a relation in which every x value has a unique y value. Okay, so every x plots to a unique y value. In other words, it does not plot to two separate y values or more than two y values. You will only get one answer when you put x inside a function. Okay, and you should be able to put all of your numbers in the domain of the function into the function and get something out on the other end. Now, the domain is essentially what you might call the range of x values which you put in. Now, in terms of functions, we normally call the domain what you put in and the range what you get out. So the domain are all of the things, the set of all possible things which can go into the function. Essentially, it's your x values when we're talking about an xy graph. And the range will be your y values, the set of values which come out. Okay, and there's some, let's just steal this, okay? So let's just take that for a moment because there's some interesting things to just unpack here, some terminology. So we've dealt with what the domain is. The domain is actually the range of all of the x values which you put in. And the range we will be talking about as just what you can get out of the y values, your output. Sometimes they call the input the independent variable because you get to choose it. You choose the number which you put into the function, and what comes out of the function depends on the function, depends on what you put in, and that's called the dependent variable. So y would be the dependent variable The independent one is the one which you get to choose, and y depends on the function and what you've chosen. Okay, so the independent variable x is also called, just to add another term in here, it's also called the argument of the function. So if I talk about f of x, x is the argument. The argument is the thing that you're putting in, the thing which you're starting with. Okay, so there's a whole load of terminology there, and there's another definition box before we get on to questions. And this one says, a relation R is a function if f acts on all elements of the domain. Okay, so everything which is in the domain can be put into the function, and you get out an answer. So there's nothing which is missing there. Now, the classic case there, you'll probably be aware of the graph of 1 over x, y equals 1 over x. And you'll notice here that you have an asymptote at this point here. So if you defined the domain to be x belongs to all of the real numbers, so any number you choose along this line, well, this wouldn't be a function if I called this f of x equals 1 over x under these conditions, because of course, when x is equal to 0, there is no answer. So every number that you have in your domain needs to give you an output. And if it doesn't give you an output, or if it's undefined, then it's not a function. But of course, you can turn this into a function by just saying, well, let's just remove 0 from the domain, and then it's now a function. Okay, so what else we got? It says as well that in the second part here, says f is well defined. Well defined means something in mathematics. It means it pairs each element of the domain with one and only one element of the range. That is to say, when you put in a number, you get out a number. You get out an answer as well. You don't get out two answers. It's not possible for that to happen. So therefore, if f contains two ordered pairs, AB1 and AB2, then B1 equals B2. What it's saying there is if you put in an A and you get out an answer, you can only get out one answer. So your B1 has to be exactly the same as B2. Now, this is kind of a very complicated way of saying, basically, you're only allowed to get out one answer when you put in one thing. That's it. Okay, and functions terminology here at the bottom as well. They say you can write y equals f of x, or sometimes you'll get x goes to f of x here as well. Yeah, sometimes you'll see things written like that as well. And just here is the definition of your function in this case. We'll see that as these things turn up in the questions. I'm not going to go into that much. Okay, so now I'm going to pop back to the questions up the top, okay, and what they're trying to get you to think of here. So they're basically trying to get you to think whether or not these are functions or not. Okay, so if we take the first set, okay, so everything in here, you can see that, for example, let's choose the graph. You put in 1, you get 2 answers out. So this cannot be a function. If you put in Belgium here, you get 2 answers out. This cannot be a function. And in this case, if you put 3 in, you get 2 and 5 out. So it cannot be a function. Okay, and obviously the ones on this side all are functions. Yes, they are, because when you put in a single number here, you get a single answer out. I mean, you need to define what the domain is, of course, but that's pretty easy. You just get all of the real numbers. Okay, and here, this is fine. You can say Neuhaus goes to Belgium as a brand of chocolate, and Leonidas, however you pronounce that one, goes to Belgium as well. And that's fine, because each individual thing you put in comes out with a particular answer. And it's fine to have 2 things going to same answer. So for example, if we chose, I don't know, if we chose this number and this number, so we choose 0 and 2 as our x numbers, we get the same height. We get -1 as the same height there. So both 0 and 2 would map to -1 in this case here. So in other words, that's fine. That's allowed for a function. And you can see for these ones here that there's no overlapping, essentially. You've got 1 going to 2, 2 going to 2. This is all completely fine. Okay, and that's because we've not got a repeat of the x number leading to a different y number. Okay, I feel like I'm kind of laboring this one, so let's just have a little look down. So for part D here, sorry, let's feel this. Okay, so for part D, you'll see that there is, B is not defined here. So there's an x value which doesn't have a defined answer through this function. So if this is the domain of A, B is without an output. So this is not a function. This is fine. This is not a function. And what you'll see later on is they'll talk about the vertical line test. If at any point in this graph, and it is a graph, sure, it's a graph, okay, but if at any point in this graph you can draw a vertical line and you get more than one place where it crosses your graph, then it is not a function. Okay, and that's called the vertical line test. Right, there is no horizontal line test, by the way, because the horizontal line test is completely fine. It's just a vertical line. At any point, you only get one answer for any point which you choose in your domain. Okay, right. So now let's actually go on to the questions. So example one here. And it says determine, giving reasons, which of these relations are functions. For those that are functions, write down the domain and the range. So for the first one, you can see that all of the x's are different and they map to values of y, which are completely fine. And we've got set brackets around these things as well. We've got that kind of bracket, the curly bracket on the side. Okay, so write down the domain and range. Well, the domain of this thing here is all of the things which you can put in. So the domain, how could we say this? The x belongs to, it belongs to our set, which is -2, -3, -4, and 0. And you might want to tidy that up by putting it in order, but that's completely fine. And y, our y values belong to all of the y answers here. So the 0, the 3, the 8, and the 0 again. Well, we only need to state the 0 once. So we've got 0, 3, and 8. Let me check that that's what they've done as well. Yeah, that's what they've done. They've stated it slightly differently. They've said D of F is equal to this set. And I've said X belongs to this set. I suppose X and Y weren't defined in this case. But yes, the domain of this function is equal to the set. But if X is the first number, as it normally is in coordinates, then you say X will belong to one of these elements in the set. Okay, so by the way, yes, that was a function. B, determine given reasons which of these are functions. I guess that this one isn't. Yeah, so if you look at this one, 5 maps to two different possibilities here. So that's not a function because you can't have 2 different answers for a particular value which you put in. Okay, let's get rid of this. And looking at this one, this is a straight line graph. So it's crossing at 4. It has a gradient of -3. So this is fine. I mean, as long as you define x as something sensible, like all of your real numbers, then if you put a real number into this for x, you will get a y number out. This is fine. This is a function. For every x number you put in, you get one y number out. Okay, well, you'll be used to y equals x squared. Looking like this. Okay, so we've got coordinate points 0, 0, 1, 1, -1, 1, and 2, 4, and 3, 9, and so on. Okay, so that's your graph of y equals to x squared. And of course, that one is a function. If we do the opposite version here, we've got y squared equals to x. And when we try and solve this, or try and rearrange this, we find out that we've got plus or minus y there. We come up with an example. If I said to you 3 squared is equal to x, no, sorry, take it back the other way. So I said y squared is equal to 9. Then if I said take the square root of both sides, that would need to take the plus or minus the square root, because of course you could put in +3 or -3. So when we take the square root in an equation, we need to remember that it's plus or minus the answer. So there are two. Okay, so y is equal to plus or -3. So when x is equal to 9, when x is equal to 9 over here, we get two answers out. We get +3 and we get -3. And that is not allowed. Okay, that's a point there. Okay, so that's not allowed because there's two answers for a particular x value which you come up with. Now you can explain this by just coming up with a little example. You say, well, when x is 9, y squared is this, leading to two answers. Or you could know about shape of the square root of x, you could draw the graph out as well. You could explain it by saying this is the positive square root of x, that's y equals the positive square root of x, and this is y equals the negative square root of x. You might know that. You might be able to plot those ones as well. So they are two separate functions, in fact, or one graph. Okay, so you might be able to put some points on there, by the way, 0, 0, 1, 1, and plus or minus 1 there, and 4 plus or minus 2, and so on. So if you plot those points, you will get this graph out. Okay, and the last one, I had to sort of read this twice actually, because I did think there was a mistake here. I thought that F was a separate question. In fact, it's a single question. It's saying we have F is mapping real numbers to real numbers. So our domain is filled with the real numbers, and the output are real numbers as well. And it's giving us this function here. Now, sometimes you'll see this as f goes to x such that, and it takes x to 1 over x plus 1. And to me, that seems to be missing there here. That's what you often see when they're talking about functions instead of writing f of x equals 1 over x plus 1. Personally, I would stick to always writing down this notation because it's more common, but it essentially means the same thing. They really should have said it's x which is being defined here, which is moving on to this thing over here, I think. Okay. So is this a function? No, I don't think so. I think there is a value for x which makes this invalid. And it's only necessary to find one value for x which makes it invalid, and then the whole thing is no longer a function. So what's the number which makes that not work or makes it invalid? Well, the number is when you divide by 0. So you can't have a 0 on the bottom. So that's the case when x is equal to -1. So you cannot put x is equal to -1 into this function. And yet they're defining the domain to include -1. So since this is undefined, so how many times can you put nothing in the bin? You can put it in infinitely many times. Okay, and that's not a number, that's a concept. Me trying to do an infinity sign. Okay, so there you go. That one's not a function. Okay, let's look at the next ones then. So, okay. So now that this is where they talk about the vertical line test, and they talk about it, but I've already mentioned that already in investigation 2, so I'm not going to talk about that now. And example 2 now asks us, just make this a little smaller, is determine which of these graphs show relations that are functions. Let's take this one here. Okay, and it's pretty straightforward. If you can draw a vertical line and it cuts it in 2 places, then it fails the vertical line test. Oh, no, it's not a function. This one, I can see that there's a position here where those 2 dots mean that those are both valid points. So you've got 1, 1, and 1, 2 there, and 1, 1 and 1, 2 mean to say that there are two separate answers for an individual input. So this is not function again, and again you can do the vertical line test. There are two places where that vertical line crosses there. This one is fine. This passes the vertical line test at a different point. So this is just a cubic graph. So this is good. And this one is good as well because you can see it's not defined at the end of the step until you step up to the start of the next step. So for example, there is only one point for 4. That is 4, 4. 4, 3, although it looks like it exists, does not exist. And they've clearly shown that by not putting a dot at the end of each of those lines. Okay, well, we're motoring with these ones. So let's look at example 3 then. Okay, might have to take these two at a time. So for example 3, we've got, it says use these graphs to identify the domain and range of the functions they represent. Okay, so for this one, we could probably just say that our domain are x values, or remember you can say d of f equals to, same thing, or r of f equals to. The domain is just 2, 3, 4, 5, and that's it. And the range, so y belongs to, and it's just going to be 1, 2, 3, and 4. 1, 2, 3 are the answers that you can get out following the answers that you can put in. Okay, now you could write that in a different way. You could say that x belongs to your natural numbers, and that x is also between 2 and 5. So that would be an alternative way of stating this thing as well. Now, later on, you'll see that they'll say x, maybe actually here as well, they'll say x is such that this is true and this is true. Well, we'll see how they build these sets as well. You don't need to worry too much about the brackets and the x's such that kind of thing. You know, as long as you've, I mean, this is totally fine here. Or as long as you've been specific in saying that this is between 2 and 5, but these are natural numbers, then that is fine. Or you could even have said they were integers there as well. It would have been fine given the separate definition to come up with that. Okay, right. So for question 2 is fine. We say, well, x belongs to the real numbers. Apart from, we need a condition on this, and that is that x can't be equal to minus 2 because it's undefined for this asymptote here. Remember asymptotes? Asymptotes. You've probably seen those before. So there's an asymptote here for when x is equal to minus 2. Okay, and so that's x, and then for y, we can see that that also gives you any real answer. It carries on forever here, and carries on forever up here. But you can see that you cannot get an answer out when y is equal to 0. So you cannot get the answer of 0 out here. So there is a horizontal asymptote here as well. For when y is 0, there's actually 2 asymptotes. Okay, let's just see what they write. Okay, so let's just steal this, and because it's kind of interesting that they're coming up with slightly different notation here. So yeah, they're saying x. They haven't said that x belongs to the real numbers. I think they really should, but they're saying this. Okay, so often you can say x is such that, so the colon would mean such that, but you can also say this line as well as such that. And so they're saying x is such that x is not equal to minus 2. But I also think that they should say x is such that x belongs to the real numbers and x does not equal to minus 2. And they've put it in this kind of set builder notation. Here we go, set builder notation. That's more than you really need to do, to be honest. And likewise, they've done it here as well. I wouldn't get too stressed about this, but stating x belongs to the integers and the x is between 2 and 5, I mean, that's sufficient, really. Okay, let's have a look at question 3 and 4. Okay, so 3 and 4 on this one. Okay, and we can see for question 3, you can put in any numbers from -3 up to 2, but because there's empty circles at the end, these two are empty circles here and here, we can say then that x belongs to the real numbers, so they're not integers or anything, they're all of the numbers on the axis between -3 and 2. But we can't put equals there because we have empty circles. In terms for y there, in terms of y, we can see there's that maximum height of 2. So again, y belongs to the real numbers, and y goes from maximum height 2, and I think it actually hits that. So we can say equal to 2, and it goes down to -5, and it stops there. It doesn't actually include -5. So there we go, that's going to be our answer. Now, with the next one, you can see that the range of this one is simply between -3 and 1. And again, you can say x belongs to the real numbers. And for y here, you've got y is between -4 and here. So it's y is trapped, height is trapped between -4 and 0. Okay, and they're both allowed. So we can put -4 there and 0. Okay, so that one should be sorted out. Okay, and you can see that's what they've written there as well. Okay, so, we are done. Right, good. So we've got to exercise 2A here. Again, get maximum practice with this. There's not many questions there, so you can do all of those ones. Okay, next time round, we're talking about quadratic functions. Thanks for listening, guys, and see you on the next one.